WLAN Security. Okay, so this is the forward here. The WLAN uses the radio as a transmission media, similar to the LAN. Sites on the WLAN share channels so that each site can easily access to the network, so without the space limitation. So WLAN security has always been a focus in the industry. The wireless authentication and the encryption technologies are constantly evolving and being enhanced. So far, the WLAN system has a series of security mechanisms to meet the requirement in the virus scenario. So in this class, we will get the graph of WLAN security in terms of WLAN security, the security tracks, and some of the security technologies. Understand the significance of WLAN security planning. Describe common WLAN security tracks. Technical principle of WIDS, WIPS. List common authentication and encryption technologies. And the last, describe the user security access technology. WLAN security overview. Wireless local area network, such as WLAN, offer a user a free network access way compared with the traditional wire access. There's no restriction. The WLAN provides the user access without restriction on the location of cable or the port, so we can move anywhere that we want to. So the WLAN allows the user to access the network for the office or entertainment anytime. Okay, anywhere such as the office building, airport, waiting hall, and hotel. So why WLAN network protections? Prevent the information theft. So wireless information interception by using the software. So communication content decryption. To prevent the unauthorized access. Okay, unauthorized user access, unauthorized resource access. Okay, we based on these two. Provide a stable, efficient wireless access. Unstable signal caused by the interference such as the raw AP. Unavailable WLAN due to denial of service attack. Okay, the security tracks. They have DOS attack, the address spoofing attack with WEP protocol, raw device intrusion, and the data theft. Then the second, WIDS and the IPS principle. IDS and the IPS, wireless intrusion detection systems and the prevention systems. So to controlling the user access security, they have the link authentication, user access authentication, and the data encryption. And the last one is the service security. The WLAN network is vulnerable to threats from the man-in-the-middle attack, ad hoc network, and the DOS. The raw device and attack pose serious security threats to the enterprise network. So all the attack can come from the downlink right now. Last time the attack all come from the external, and now the attack can come from the intranet. WIDS is used to monitor the running status of the network and the system according to the security policy, analyze the user activity, determine the intrusion event type, and detect the emailing network. So basically for this feature is used to scanning and monitor all the traffic. For the WIPS, the prevention systems. So monitor the network in the real time to proactively defend against the detection intrusion. So based on the intrusion, the detection that we already ran, so the WIPS can able to prevent certain type of the attacking. AP can work in two modes, normal and the monitor. Transmit common WLAN services if the air scan is disabled. Okay, when we don't enable any air scan, so I just purely want to provide the normal service access for all my clients. Transmit WLAN service data and provide the monitoring function. If AirScan is enabled, so monitoring may affect the WLAN service data transmission. Then the next, the monitor mode. Provide the monitoring function, but do not transmit WLAN service data. So this is just purely doing the monitor. The raw device identification process. The AP report information about surrounding device. So start. The AP will go to scan the surrounding and try to identify all the device. So first, they try to categorize all the device first. So this device is belong to the AP, wireless bridge. Is it the STA or the ad hoc? So let's start from the AP and the wireless bridge. So now they already categorized this kind of the wireless access is the AP. So okay, this device, the AP, is it this local AP connected to the AC? Currently this AP connected to my controller or not? If this AP never connect to my controller, I will assume this one is the unauthorized AP. Okay, so the last one I'm going to check. Is it the AP in the whitelist? If the AP is not in the whitelist, then that means this is the raw AP. Then the next one for the STA. So they're going to check. Right now the STA is connected to the AC. If no, is it the STA right here is connected to another AP? If yes, then this is a raw client. Right now this PCI is not connected to my controller at all. So that's why I will assume this STAs belong to the some unauthorized user. And the last, the ad hoc. The ad hoc is always the raw device. The monitor AP scans channel to monitor all the 802.11 frame sent from surrounding wireless device. Based on the 802.11 MAC frame type, the monitor AP can identify the type of surrounding wireless device and further identify raw device through the raw AP client detection process. Okay, if we're going to change the AP become the monitor AP, so that means right now this AP can't able to provide any services to the access user. So it's just purely for scanning purpose. So they scan the surrounding. So they can able to monitor the raw AP, the client ad hoc. The ad hoc is happening to those PCs running the like the infrared, Bluetooth, the point-to-point connections all belong to the ad hoc. Okay, and also the wireless bridge when the AP running the WDS. So WIPS support content the containment on the raw AP, the raw client, and the ad hoc device. So when they're able to detect all the unauthorized access from the device here, so this is not the authorized device. So this monitor AP, we're going to start to send the association frame. They're going to ask all of those clients leave the association. I will not going to connect with all of those devices. Okay, they'll do this one automatically after we enable the WIPS. Okay, other functions supported by WIDS, WIPS. The fraud attack detection through WIDS. Okay, spoofing attack detection through WIDS. So basically the WIDS can able to detect all those attacking. The fraud attack, the spoofing attack, the weak IP detections, and defend against the brute force PSK cracking. AP Authentication Technology. MAC address authentication by default. So how the AC authenticate the AP? So previously I did mention when we're doing I showed the configuration on the web. So they support the MAC authentication, the serial authentication, and the non-authentication. So this is for the security purpose. Then the authentication-free whitelist function. So we also can create the AP whitelist. You can just simplify to register all your AP MAC address and put into the whitelist. So that means this kind of AP, right, it doesn't require to perform any authentication. So when I check on the MAC address is inside the whitelist. So this AP is always the authorized AP. Okay, so the whitelist can use for the the WDS and the mask. The WLAN user access security. The WLAN security involves the following: the user authentication, prevent unauthorized user from accessing the WLAN. So all the users have to perform the authentication first before they access the WLAN. And the data encryption. So after the user can able to connect to the WLAN, so the next thing we need to do is we need to make sure all the data, the information sent from a user is protected. Okay, all the information must be encrypted. So Huawei actually support the following security policy: the web, okay, open system and the share key authentication, plus the WEP encryption. WPA, you can using the PSK, the pre-share key, EAP authentication. The encryption, they have two different formats, TKIP and the CCNP. WPA2 is the enhanced version of the WPA. Okay, they're both doing the same authentication and also the encryption. And the last one, the WABI. WABI is using the pre-share key, or you can using the certificate-based authentication. Okay, for the encryption, using the ECC. Then WEP is use the RC4 algorithm, so it's easy to decrypt. Okay, this is happening to the last time the encryption algorithm. So when they're using the RC4, WEP use the static key, which is difficult to distribute and maintain. In WEP open system authentication, the user can access WLAN without the authentication because it's open. Okay, the user doesn't require to perform any authentication. WEP open system authentication plus the web portal authentication. Yes, so this is the most common use right now. So if you want to do the captive portal authentication for all the user, you have to set the authentication type become WEP. Okay, so basically for this kind of authentication, it's using for the guest access scenario. Okay, we create this one for the guest access. WEP is not recommended in other scenario. WPA, WPA2. Okay, they both is very similar. They both support PSK and EAP authentication modes. So they both support TKIP and CCNP encryption. So this is for the data encryption. The precaution. In the pre-share key, the authentication mode. So both of them does not require an AAA server. It doesn't require. So and suitable for the small and the medium-sized enterprise. In the EAP authentication mode, the WPA, WPA2 require an AAA server. Okay, that's a different. For the pre-share key, the PSK, you don't need to have the AAA server. Only in the EAP, you need to do the you need to have the AAA server and provide the high security, applicable to the medium and the large size enterprise. So at the same time, they also support the EAP type, such as the PEAP and the EAP TLS. And the last, to deploy WPA, WPA2 on 802.11 network, you must configure CCNP encryption. If other encryption modes are configured, the network will be rolled back to the non-802.11n network. WLAN authentication infrastructure, identity authentication and the key management. In WPI, the privacy infrastructure, this one is used for the data encryption, authentication, and replay the attack defense. The advantage, the bidirectional identity authentication. So they do the authentication on the both sides. The digital certificate as identity information and well-developed authentication protocol. So this protocol is definitely different than the those of the encryption that the EIP that create on the WPA. Okay, it's different. STA in some country might not support WABI. Okay, because this kind of authentication, right, they actually create on the state in the China. So some of the STA our end devices might not support. So other WLAN security protection mode. So we have the STA blacklist and the whitelist. So for this one, we can configure the MAC address to block the access user using the blacklist or the whitelist. Then user isolation. So to prevent all the user can able to access to each other, so we can isolate the user. The MAC address authentication. Okay, I can base on the MAC address and authorize the user using the MAC address. Or we can using the web portal. And the last one, anti-spoofing technology such as the DHCP snooping, the dynamic ARP inspection (DI), and also the IP source guard, okay, IPSG. Now this is the blacklist and the whitelist. The blacklist and the whitelist can be used to filter the STA to control the STA access. The STA blacklist and the whitelist can be deployed based on the AP. Okay, so maybe we have multiple of the AP, and this AP, right? The blacklist and the whitelist, I don't want to apply to all the AP. So you also can base on the AP and apply the whitelist and also the blacklist. Okay, which one have and which one you don't have. And this kind of services, the feature, you also can deploy based on the service set. So maybe this PC, okay, maybe I have a STA 1, STA 2. So when they want to try to connect to the Huawei number 1, it's blacklist. But on the another Huawei number 2 SSID, I never set the blacklist. So these users can still connect to another SSID. Okay, so this one will be based on the service set. Then the last, only one blacklist or the whitelist can be deployed on an AP. You cannot using blacklist and the whitelist at the same time. Okay, they only allow you to choose one. So when starting, you check the STA access control. So which one that we enable, whitelist or the blacklist? So if we enable the whitelist, so now they're going to check, did we have configured any MAC address inside the whitelist? If yes, okay, now they're going to check. Okay, if yes, the STA is inside the whitelist, then the PC can go online. If no, okay, right now my PC is not inside the whitelist, then you're going to check, is the source MAC address in the whitelist? Okay, if yes, they can go online. If no, they reject. The blacklist will be very simple. If the MAC address is inside the blacklist, of course they're going to deny. Okay, it's just by this way. MAC address authentication based on the MAC address of STA. So the STA inside the MAC address authentication. So I already pre-configured this MAC address on the controller. So when this PC want to connect to the SSID, right, they actually doesn't require to put any authentication password. They can bypass it. Okay, they can always connect it without entering any password because they're already inside the MAC address authorized. So support the guest VLAN and the user group authorization functions. Support the cooperation with other authentication modes, okay, like WPA, PSK. Then the next one is the web portal authentication. Support the built-in and the external portal authentication. Of course, the Huawei AC also built with the built-in portal, so we can using the Huawei built-in portal to perform the web portal authentication. Or maybe on the company they already have another server can provide the same services, so you just select the external portal from the controller there. Okay, then the user will going to redirect to the external portal. So this one can support the layer 2 and also the layer 3 authentication. Support the keep alive and user authentication management function. And the user can do the self-registration. The next one is the anti-spoofing technology. So the first one, DHCP snooping. So it's used to defend against the bogus DHCP server attack and the DOS attack. Defend against DHCP packet, fraud attack, and the spoofing attack. And the next is the defend against the non-DHCP user attack. Okay, so this is the feature for the DHCP snooping. Then the next one, the DI. So defend against the ARP spoofing attack and the fraud attack. So this one always have to enable together with the DHCP snooping. You cannot just enable the DI itself. Okay, they will not allow you to do that. So if you want to enable this defend, you have to start the snooping first. Okay, then you can enable this. The last one is the IPSG. Defend against the IP address spoofing attack. And the last one, CAPWAP Encryption and the user authority management. The CAPWAP control tunnel can be encrypted using the DTLS. Okay, the CAPWAP control tunnel, because the control tunnel by default they actually doesn't using the DTLS. We have to enable that. Okay, if you want to protect your information. So we've enabled the DTLS can prevent the control message delivered by the AC from being intercepted. So it supports the following authentication mode. Certificate-based authentication. So the AC and the AP are delivered with the certificate. Or we can using the pre-share key. So the default password after we enable the DTLS, and we're going to using the pre-share key. So the default password for the Huawei controller is using this, the Huawei set CWP. Okay, and of course the password we can modify it later. VIP based user isolation. So the VIP base, once we already enable, all the user connected to the same AP here, they are not allowed to form the communication. They can't able to reach to each other. So this one is used to ensure the user service security and the charging accuracy. Then the next, the user group based the user isolation. So the group based user isolation, we have two different types. The first one is called intergroup isolation. So when the user belongs to two different groups, or just make it simple, this is the two different SSID. Okay, we assume this is two different SSID. So these two different SSID, the intergroup isolation, this one, they are not allowed to form the communication. So if you connect to Huawei 1 and I'm connected to the Huawei 2 SSID, so these two users, they can't able to ping to each other. Okay, it will be failed. Then the other one, intra-group isolation. So once this one is already enabled, okay, this one is belong to the same group. So the same group user, after apply the intra-group isolation, even the same user in the different user in the same SSID, they are not allowed to reach to each other. Okay, they will be totally blocked. And the last one, they can combine these two together. Okay, summary. WLAN security overview. Okay, I did explain what is the overview on the security and the WIDS, WIPS principle, user access security, and the last one is CAPWAP encryption and the user authority management.